Hello, my name is Kartik Joshi and I am completed my master's in electric engineering. So today I'm going to explain that what is eigenvalue and eigenvector. So let's start. First of all, we are considering a vector. That means consider this is the vector A. So now we are going to transform the vector A. That means here we can compress or stretch. That means if we are going to stretch this vector A by 2 times, and let's suppose the vector A is in direction of northeast, and it's having the length is 2 centimeter. And if we are going to stretch the A vector by 2 times, that means I'm saying that it's becoming a vector something else. This is say that a dash vector and size is 4 centimeter. That means its length is 4 centimeter. So how we can understand that some vector is transforming in the stretching, in the compressing, some vector are rotating also. Just for example, if the A vector is there, and if I am going to rotate 90 degree anti-clockwise, then what happens? It's become the something else vector. That means a dash vector. So if we are going to transform the vector, here is the meaning of first we are explaining, I'm explaining the eigenvalues. If we are going to compress during the transformation, that means its value is given by its eigenvalue. Its eigenvalue. And how much compress is given by eigenvalue, and how it stretches, in which direction it is stretched, it is given by its eigenvector. It's very basic concept of the mathematics and very easy to understand. Let's have one example that we can easily understand this concept very well. So this is the first example. I'm going to uh, get the answer A and B. Here are two sub questions of A1 and A2. So first question is find the characteristic polynomial of M. So here is the M. M is our basic matrix. It is the basic matrix. We are going to find the characteristic polynomial. So first question in our mind that what is lambda? That's one question in mind. Lambda is eigenvalue. Lambda is eigenvalue. And if you are having the matrix 2 cross 2, that means you have two lambda. Lambda 1, lambda 2. We are going to find lambda 1 and lambda 2. But how we can find the lambda 1 and lambda 2? By using the characteristic equation. By using the characteristic equation, we can find easily what is the value of lambda 1 and what is the value of lambda 2. So, first of all, here is the matrix. M is equal to 7, 2, 2, 4. And here is the one formula to find the characteristic equation from the matrix. What is the formula? Formula is in the modules. M minus lambda I is equal to 0. M minus lambda I is equal to 0. And what is the I? I is identical matrix. Identical matrix. So step by step, we can find the solution of M minus lambda. And what is determinant? Determinant is I explained in the later ones. So put the value of M, lambda, and I. Here we are not going to, we are not know the value of lambda. So we are going to find the value of lambda. So here in this equation, put the value of M. M is 7, 2, 2, 4. That means lambda, we don't know. And what is the identical matrix? 1, 0, 0, 1. And here the determinant of it is equal to 0. So this basic subtraction is there. But first of all, we are going to multiply lambda with every terms in the identical matrix. Every terms in the identical matrix. So here is 7, 2, 2, 4 minus lambda into 1, lambda, lambda into 0, 0, lambda into 0, 0, lambda into 1, lambda. It is equal to 0. So now the basic multiplication, basic subtraction is there. 7 here, lambda here, 2 here, 0 here, 2 here, 0 here, 4 here, lambda here. So this is the 7 minus lambda, 2 minus 0, 2, 2 minus 0, 2, and this is 4 minus lambda. Now it's time for the determinant. Now it's time for the determinant. So what is determinant? For finding the determinant, I will give the example of here. A is equal to, let's suppose, small a, b, c, d. And we are going to find the determinant. That means, first of all, you have to multiply a into d. Multiply a into d. And then multiply c into b. C into b. And then subtract. This is the formula of a. That means determinant of a. It is very much easy. So we can say that 7 minus lambda into 4 minus lambda minus 2 into 2 is equal to 0. That common multiplication is that 7 4 that 28. Then 7 into minus lambda minus 7 lambda. Then minus lambda into 4 minus 4 lambda plus lambda square minus 4 is equal to 0. That means the lambda square minus 11 lambda plus 24 is equal to 0. Then how we can the part is this, and how we can find the values of lambda 1 and lambda 2 from this characteristic equation. First check this is right or wrong. First check is this right or wrong in our answer. Lambda square minus 11 lambda plus 24. Yes, we got the right answer of our characteristic equation. Now we have to find the value of lambda 1 and lambda 2. That means C and 8. We are going to find the value of lambda 1 and lambda 2. So we are going to part the, here is 1, here is 24. Here is 1. Here is 24. That means 1 into 24. That answer is 24. Part the 24 in that way that we got the answer in multiplication 24 and in subtraction 11. Subtraction 11. But both sign is minus. So we can say that in addition 11. So we got the answer is 8 3s are 24 and minus 8 minus 3 is 11. So here is lambda square minus 8 lambda minus 3 lambda plus 24 is equal to 0. Common the lambda in first two term, common the 3 in third and fourth term. That means answer is lambda minus 8 minus 3 lambda minus 8 is equal to 0. That means we get the two bracket lambda minus 3 is equal to 0 and lambda minus 8 is equal to 0. So the answer is lambda is 3 and second answer of lambda is 8. So now we are going to find the eigenvector. First check this is the lambda value is right or wrong. So here is the lambda 3 and lambda 8. It is the right. Now the option is B. B is the find the eigenvector M. Okay. So here the lambda's value, lambda 3 and 8. So what is the formula to finding the eigenvector? It's time to finding the eigenvector. Finding eigenvectors. So first of all, we know the MV is equal to lambda V is the formula of eigenvector. And then what is the value of M? M is our given matrix. What is V? V is our eigenvector. And what is the lambda? Lambda is our eigenvalue. So here MV is equal to lambda V. So first of all, value of M is 7224. That means here value of M is 7224 eigenvector X, comma Y. Yes, and here's the lambda. What we can say the lambda, first take the lambda is equal to 3. First take the lambda is equal to 3. It is the take value of lambda is equal to 3. Okay, so multiplication rule. Multiplication means 7 into X and then 2 into Y. So here 7X plus 2Y is equal to 3X. That means 3X is coming this way and 2Y coming this way. Yes. That means 4X is equal to minus 2Y. That means 2X is equal to minus Y. Is this the equation of 2X is minus Y? So what we can do? We can take the value of X is equal to 1, or then we get the Y is equal to minus 2. Yeah, it is also happen. Yes. So here is the answer. If we take X is equal to 1, we get the y is equal to -2. So take x is equal to 1. Always you can take the x is equal to 1, x is equal to 2. But first, for the finding of the eigenvector v1, you have to take the value of x is equal to 1. Then you have the answer of y is equal to -2. So here is your first eigenvector. If we take the value of lambda is equal to 3, you get the eigenvector v1, that is the value of 1 comma -2. Okay, this is very basic. Now you are going to value lambda is equal to 8. Second value of eigenvector, take lambda is equal to 8. So what's happening? Same formula is there. Mv is equal to lambda v. What is the value of m? 7224. 7224. What is the value of v? X comma y. What is the value of lambda? 8. So here we are going to multiply 7 into x with 2 into y. It is equal to 8x. So 7x plus 2y is equal to 8x. And your answer is we can say 2y is equal to x. 2y is equal to x. Now we are going to first for the finding of the eigenvector v1, you take value is x is equal to 1. Now turn x is equal to 2. So take x is equal to 2 and your answer of y is 1. So now we get the answer of the second eigenvector v2. If we let the lambda value is equal to 8, your answer v2 is equal to 2 comma 1. Right? So here it is, we can find the both eigenvalues and eigenvector and in a beautiful manner. So that's it. Goodbye.